So we are lucky to have Prasad here with us today. He works as a senior a specialist solution cloud architect at Red Hat. I'm also happy to share that he's one of the co-author for the book titled Mastering KV Virtualization. So stage is yours, Prasad. Go ahead.
Absolutely. Thanks, Ambal. Thanks for this opportunity and good morning, everyone. And thanks for joining this session. Robin, that was a great session. Okay. Uh, and I think I'm in the line. So there was a question on hybrid cloud. So that's what I'm trying to cover in this session. I will cover the project called the Submariner.io, which helps to build the hybrid cloud solution. I will get deep into this. Why Submariner? Why not any other IP tunneling? Those are provides the connectivity between the two clouds or between the on-prem and public cloud infrastructure. But why we need to go through the cloud native way or the Kubernetes way? And this Submariner project is something that provides the uh, networking, multi-cluster networking using the native way. So this is what I'm going to cover in this session. And yeah, I work for Red Hat. I'm a part of the specialist solution architect, and my area of specialization is in two field. One is the automation, and the second one is the infrastructure. I'm a hardcore infrastructure guy. Let's keep this session as interactive as possible. If you have any question, you can stop me also, and let's try to keep it interactive. So let me start with a very basic thing. Hybrid cloud. I mean, if you look at the hybrid cloud, it has been a phenomenon. Okay, a lot of organization love to go. Love to adopt the cloud in a hybrid cloud fashion. The reason behind is that it provides a lot of benefits. Okay, so there is a no fixed definition for the hybrid cloud, but as per the Wikipedia, Wikipedia says that it's a blend of private public cloud infrastructure that allows organization to leverage the benefit of the both environment, and that those benefits includes first thing is that avoiding the public cloud lock-in. Okay, that is a very big thing for any organization. No organization would like to get into the lock-in with one single uh, public cloud or hyperscaler. Okay, they need that flexibility so that they can move from one cloud to another cloud or cloud to back to the on-prem infrastructure, and that is the core of the hybrid cloud. When you go into the hybrid cloud, you will not get into lock-in of any kind. Even on the on-prem, you are using the VMware or any other those enterprise grade virtualization platform, you will still be able to move the workload very seamlessly from that on-prem to the public cloud and vice versa. Okay. The second thing is that it increases the business continuity. I mean, if I'm an organization and I'm running one business critical application for my end user, though, so in that scenario, I expect business continuity and data protection as the highest priority. Okay, if I run everything on a single cloud, although you will get that uh, zones and availability zones and other things, but still, it's still there are the chances where complete region will go down and other thing. But if you go with the hybrid way, you have more reliability and insurance on uh, business continuity part, and flexibility and scalability is already there in the hybrid cloud. Okay, but same time hybrid clouds also brings the challenges. If you want to adopt the hybrid cloud, the first challenge is that diverse APIs. When I say the API, it's not just the API. I mean the REST API. Their interface will be different. Their SDKs will be different, and because all those front end will at the end will communicate through the API. So if those APIs are different, you need something through which you will be able to manage everything through the single console kind of thing. Okay, that is one thing. Difference in monitoring and logging that is there, because if you are going with the on-prem and then you have a public cloud, there will be some difference. Okay, if you are using a native. Security may be a reason because you don't know. I mean, if you are following the best practices in the cloud, on-prem when you are exposing the application to the external world? Are you really following those all best practices, security scans and other things? So there is a challenge on security also, because if you are using some product in on-prem, that may not be applicable to the cloud. So that challenge is also there. But the biggest problem in adopting the hybrid cloud is a networking, right? So how you will connect to networks? You have on-prem and you have the public cloud. You can create the tunnels and other things, but when it comes to the applications like Kubernetes, how, because Kubernetes uses the overlay network. You have the underlay network. On top of that, you have the CNIs, and that CNIs are nothing but it's a overlay network. You create a completely virtual network. Okay, and then you have the concept of pod network, service network. If a pod wants to talk to the other pod, it can directly talk over the pod network. And another best thing is that we have the service network. Usually, how we communicate within the OpenShift or the Kubernetes cluster is through the services. If one application wants to talk to other application, you just put the service in front of that and you talk to that. But when it comes to multi-cluster, how you will be able to do that, right? So, and when I put this aspect, so this is the scenario, a customer or maybe a user that is having a three different kind of Kubernetes. One is using the Red Hat, OpenShift, Rancher is there, or someone has deployed open source vanilla Kubernetes. Okay, how they will connect it with each other? Because you can of course create a tunnel, but if you put the tunnel, how, I mean, you have to expose the application to the external world. You need to get that application on that tunnel network. Okay, that is a problem, because the advantage is that what I want is that in OpenShift cluster, I have created application. I expose that application to the service. And the second cluster that I have in the Rancher, that should be able to talk to that application over the service network. It should not get into the public interface or the tunnel. How we can achieve that? So that's the biggest problem if you see when it comes to the OpenShift adoption or the Kubernetes adoption in the hybrid cloud. Okay, sorry if I'm getting the OpenShift in my, while I'm talking. That's because I'm very, I mean, I regularly talk about the OpenShift. That's why it's coming in my talk. But when I put this aspect of hybrid cloud in Kubernetes, I want to achieve the hybrid cloud in Kubernetes. I have two options. One is that I can create a staged cluster. Okay, you have a Kubernetes cluster in which you have a three masters and two workers. All those are running on your on-prem. Okay, maybe the VMware or Proxmox or any other virtualization, or maybe you are running that directly on the bare metal. Okay, and then you have two workers running on the cloud. Okay, so this is a stretch cluster. You are stretching your cluster between on-prem to the public cloud. That is the one approach that is available. While this approach is possible, but there are a lot of problems and prerequisites in order to adopt. The first thing is how you would span your storage. If you have the storage, okay, in VMware, maybe you are getting the storage from the data store. Will that storage be available in the cloud? It will not, correct? And network services, how you will expose that network services between the two different environment. Resiliency, if I am running a three master in my on-prem or vice versa in the cloud, what will happen if that cloud goes down or on-prem will go down? So all those problems are there with the stage cluster. While stage cluster has its own benefits, there are a lot of trade-offs also. Okay, the second approach that we can adopt is having a separate cluster. You have a one cluster, okay, in your on-prem environment, and second in the cloud. But that will put some more operational overhead. I think that is manageable. But again, the most problematic thing is networking. How you will manage the networking, right? I don't want to expose my application on the public network. I want those applications to be available on the service network only, Kubernetes service network, but should be able to communicate between the two clusters deployed in two different environments. If we can achieve this, that is the best way to adopt the hybrid cloud for the Kubernetes. Okay, and this is what the project Submariner provides. Okay, the solution for this networking problem is the project Submariner. It enables the direct networking between the pod and service in different Kubernetes cluster, either on premise or in the cloud in a true hybrid way. Okay, what is the Submariner? It provides the cross cluster L3 connectivity using encrypted, and I mean we will obviously go with the encrypted one, but maybe there are the use cases where you not worried about the security, you are just worried about the speed. It also provides the unencrypted connection service discovery. Okay, that is again, you will set up the networking, your pod is able to talk to each other in a different cluster, okay, without getting outside the cluster or without getting exposed to the public network. But how you will be doing the service discovery? Okay, because service discovery is one of the very core element of the Kubernetes. Why Kubernetes is so flexible or so good, I would say, is because of the service discovery and this L3 network, pod network, this core objects or the core services that Kubernetes provides. That is, I mean, that is what helps to get into the cloud native space, right? So then there are the commands support interconnecting cluster with the overlapping CIDR. So again, this is something a bit advanced. Let's say you have a two clusters, okay, and those two cluster are using same CIDR, okay, same CIDR for service and the pod network. In that case, how you will be able to achieve the connectivity between them? For that also, it has something called the global net option that allows you to connecting the two cluster with overlapping of CIDR. Okay, it's a CNI agnostic, and it has to be CNI agnostic because if you have a Kubernetes cluster in on-prem and then you are using the managed service, there will be a different network layer, different CNI. So it has to be a CNI agnostic, and it's rightly CNI agnostic. I mean, it can work with any CNI. You bring any CNI, it can work. Okay. So what benefit Submariner provider is that you have pod to pod and pod to service routing with a native performance. So basically you eliminate the need of proxies, external load balancer, ingress for east-west traffic. When it comes to the two cluster, we consider that it's a east-west traffic, right? So for that east-west traffic, you will not require any proxies or external load balancer. Enhance the security, data plan transparency, and deploy service across cluster. These are the benefit, but the most prominent benefit of the Submariner is that you have pod to pod and pod to service routing with a native performance without using any proxies or external load balancer. Okay, and how it works, if I zoom into the architecture of the Submariner, so basically we install this gateway nodes, and this gateway nodes enables the tunneling. So it uses the tunneling. IPsec is what it uses in backend, and then you install its agent, routing agent on all the worker nodes, and the worker nodes will use that agent to communicate with the gateway node, and then you have the connectivity. Okay, and Submariner has a broker also. This broker actually stores all the metadata, whatever the metadata that you are storing into the etcd before getting into the etcd. It also gets stored into the Submariner broker, through which it will be able to do the discovery of the services. So this is a very high level architecture. If I get into the elements of the architecture, these are the elements. The first one is the gateway engine, which manages the secure tunnel to the others. And these are the tunneling that we support. First one is the IPsec implementation using the Libre S1, and WinGuard is also there. And then you can have VXLAN and unencrypted. So this is how you can create the tunnel. This is all automatic. Okay, you just need to install the gateway engine. then pass the what is the implementation of the tunneling that you want to use. It will do all this automatic. I mean, you don't need to get into the low level and configure that tunneling between the two cluster or the two network. Everything is automatic when you go with the Submariner. That is one of again very good advantage over doing the tunneling and other things manually in order to achieve the hybrid cloud. The second one that is there in the architecture is the route agent, which you install on all the nodes, okay, all the worker node, and this gives the information on the, I mean, it creates the virtual network or one more network layer on your pod and service network through which the traffic passes. The broker, then we have the broker which facilitates the metadata between the two gateway engines. So metadata, so whatever, this is how, I mean, the service discovery happens. Okay, then we have the service discovery, which provides the DNS discovery across the cluster, and GlobeNet controller is something that handles the overlapping CID. Okay, but the thing that I want to you to understand is that this is the solution. This is the project that will allow you to truly set up the hybrid cloud, and it has a lot of flexibility. Okay, I can use a different IP tunneling. Now you can do the automated installation. The agent installation on the node is also can be automated. That means you can just have one post provisioning task in your cluster deployment. So your cluster gets deployed first. Once the cluster is deployed, your agent gets deployed, Submariner agents get deployed on the all the nodes, and then its Helm chart will allow you to install the complete gateway engine and route agent for you. Okay. So how we can do the deployment? Absolutely. I mean, there are multiple ways, but these are the three very common ways to install the Submariner in a Kubernetes cluster. The first one is the operator. Okay, you install the operator, and it is a fully automated. The life cycle of that operator is also fully automated. Upgrade and all those functionalities provided out of box. Okay, so it's available on Operator Hub. You can download that operator and install on any Kubernetes cluster. Second one is the Helm chart. So the charts are available. You can install the Submariner by using the charts. And third thing is, if you want to tinker around it, if you want to get more how it works and other things in a hard way, then there is a subctl command also. Using the subctl command, you will be able to install the Submariner. It is a bit lengthy procedure when you go with the subctl, but you will get understanding of what is actually happening. And you install the Submariner, what are the changes happens in the cluster, where you open the port, what are the port those are opened, all you get the detail. Okay. So those are the deployment action, and now getting into the configuration. You have deployed your Submariner, and then if you want to make some configuration, what are the ways to do that? Okay, it introduced the three concept. One is the cluster set. It's a group of the cluster. I mean, how many clusters you want to connect with each other. Those details you provide in the cluster set. Service export. You have a option. Either expose all the service between the two cluster or expose the particular service. So using the service export, you can define which service you want to export. If you don't define the service export, by default, it assumes that all the services, those are available in both the cluster, can see each other. Okay, service import, multi-cluster. So representation also set. So it's a DNS input. So I mean discovery part. So that you can do through the service input. So these are the configuration elements for the Submariner. Okay. So in action, when I install the Submariner completely, what is the benefit that I get? You'll have a networking first pod IP network. This pod wants to talk the pod in the cluster to, it will be native, like how this pod will talk to the other pod in the same cluster, the same way it will talk to the in other cluster also. Okay, so that is the one functionality. Service discovery will automatically happen with the load balancing. The service that you have defined in the cluster when will be able to available to the service B also. If this pod want to talk to one of the service in the cluster A, it will be natively able to do. It will not need to go outside the cluster. I mean, that load balancer or node port, you will not need to use any of those things. It will be native. I mean, it will be something like how it is talking to within the cluster, same way it will be able to talk. And if you create any network policy, the same network policy can be shared between the multiple clusters. So this is, I mean, there are a lot of benefits. I have a section on the use cases, but when it comes to the multi-cluster management, one thing is the API management. For that, there are a lot of fleet management softwares available in the market, in open source, as well as in the commercial space. But when it comes to the networking, interconnectivity, multiple cluster with each other for the east-west traffic, Submariner is the best project available. There is a project called the Scupper, but that works on the layer 7. It's a bit different approach that it has, I mean, the Scupper has used. But if you are looking for a traditional way to connect the multiple clusters with each other, we have only option, that is the Submariner. Okay, so before I get into the use cases, so do you have any question? Should I take a pause here? Anyone, any question? I mean, is it relevant to what you have been doing? I mean, any
Yeah,
questions?
yeah, I think we have one question from Nilanjan on the chat. For Nilanjan, do you want to speak up?
Yeah.
Yeah, sure. So, just a simple question. By the way, great topic, Prasad. I'm really impressed by Submariner. So, I was just thinking about the architecture deployment pattern used for the Submariner here. I mean, it almost looked like a single point of failure when the Submariner is deployed. So, how do we ensure the HA for it, or rather, how do we ensure that it's resilient when it's deployed across scale?
That's a great question. So it's not single point of failure there in the Submariner. We can have a multiple gateway. The more gateway that you will build, you will have more resiliency. So here you can see that I have two gateways. Why I put the two gateways? Because I need the resiliency. Well, if one of the gateway node goes down, then the communication will not happen. But if I have multiple gateways, and that is again a configuration parameter where you will define how many gateway nodes you want. And that's why you will be able to achieve the resiliency.
Awesome. That makes sense.
Okay. Okay, so let me get into the use cases because this is interesting. You have two clusters, and what is the use case? Why someone would interconnect the two Kubernetes cluster in a hybrid cloud? Okay, the first use case that comes in my mind is that you have I mean, connecting the multiple clusters require inter-service communication. Okay, so you have a database running in the cluster A. Okay, there is a front end that is coming. Okay, but for the resiliency or business continuity perspective, you want one more cluster. Okay, it's completely separate because of the compliance and other reason. And then you have deployed a front end service in that front end service. Instead of doing the replication other things, because replication is already managed at database level, your service will directly able to talk to the database in a very native way. Okay, so secure service to service communication is one use case. So you have the application, those are spread across the multiple clusters, and now they will be able to talk to each other in a very native way. That is the one use case. Second use case is that you want to share the services. Okay, you have deployed a vault. I'm taking a vault as one example in one cluster. Okay, now you want to share that between a multiple cluster. So by using the Submariner, you can, I mean, create that connectivity, inter-cluster connectivity, and then you will be able to expose or maybe share the service like a vault. So vault, we want to be able to, so vault, you can put that into the public space and then share, but that will be less secure. But if you go with the Submariner, it will be the native. The first thing is the performance will be higher because you will have a lesser hops between connecting between the two clusters because it's a native one tunnel only. The second thing is it will be a more secure, right? Because your pod is directly talking to the service that is native to the Kubernetes. It's not getting egress or ingress, those things are not happening. That is the second use case. It can be any other shared service. Okay, and third use case that I see is that a disaster recovery. Okay, so you have a front end database. Database is backed by the persistent value. You can do the replication of that persistent volume between the two sides, and then your services, front end and back end services, can talk to each other. And for the replication also, because it's a volume, so that volume replication can happen over the Submariner data. So there is also very good use case for the Submariner. You put the Submariner, connect the two clusters, and over that two clusters, you will pass the volume replication data, and you will be able to achieve the disaster recovery environment. Okay, so that's what I wanted. I had a very 20-minute slot, so I wanted to cover whatever I can cover in this 20 minutes. So yeah, so I recommend all of you to visit the Submariner IO. They have a very good documentation, and it's a great project. Okay, although it is not a part of the CNCF because it's not that large project, but it is being adopted at a very large organization. I have seen that a lot of big banks in the US and Europe region, they are using the Submariner in order to achieve the hybrid cloud. So it is a great project. So I recommend everyone to have a look at the Submariner and see how you can adopt it, what use case you can solve by using the Submariner.
Good. So thanks a lot, Prasad. It was like a really good session on hybrid cloud networking, and thanks for introducing us to Submariner. I hope Submariner will make its way to CNCF landscape soon. So thanks for sharing the different use cases it solves. Thanks a lot.
Thanks, Ambal. Thanks, everyone.